is using indirect measurements. So we want to find the lengths of similar triangles. So here we have a scenario where we have two triangles. So if we can prove these similar triangles, then we can go ahead and set up our proportion and solve for x. Okay, so what we know is we have right angles. Okay, so therefore I have angle T and is congruent to angle S because they're both 90 degrees, right? Angle T is equal to measure of angle S because they're both 90. They're both right angles. So I got one angle, and now all I know is that right here, if it reflects at the same angle coming down, it's going to reflect back at that same angle. So I know this angle and this angle is actually congruent as well. So angle, say TVH, is congruent to angle, what would that be? SVJ, right? The angle in question is V, so I need to put that in the middle, right? And because since it's 1V, I don't know if I'm talking about the left or the right, so that's why I can't just do angle V is congruent to angle V, okay? All right, so therefore, since both those triangles are congruent, right, because they're reflecting at the same reflecting angles, then I can say that, okay, that the two triangles, triangle TVH is similar to triangle uh, SVJ by angle similarity. So then I can set up my proportion, right? 5.5 over 6 is the same thing as x over 34, and now I can multiply these and go ahead and solve it. So I get 187 is equal to, multiply these, or I don't even have to multiply those, well, really, because I'm just going to divide by 6 anyways. So divide those, and I get x is equal to 31.2. Okay, so that's how you do that. And here's your thing right here. Just use that same problem. And why is it important that it's flat against the ground, right? So why can't the ground be like this when I measure those? So answer that.